Hi everyone, welcome to this video. So this is Ingenuity Tuition Center. So today I just want to solve one question that was asked by one of our subscribers. Okay, so one of our followers asked us this question, and we want to help the person solve the question. So let's do it for them together. Okay, yeah. So this is additional mathematics, and the question reads: the diagram shows the curve y equals 2 minus x squared intersecting the straight line y equals negative x at A and B. So you can see we have this curve, okay, that meets this line y equals negative x. They meet at 2 points, at A and B. Okay, so what are the questions? Okay, so the question says determine the number one, the coordinates of A and B. So what are the coordinates of A and B? Then the other question says find the area of the shaded region. So what is this area that has been shaded there? Okay, so let's just do it together. Okay, so I'll first of all start with the coordinates. Okay, yeah, but because it talks about finding the area, we'll use something called integration. Okay, calculus. But before I just start solving the questions, let me just give you an idea of what integration is all about and how we're going to apply it here to solve the question. I want you to understand every step. Okay. So first of all, let's just briefly talk about integration, how we can integrate functions and how we can now use integration to determine the area. Okay. So let's just make it quick. Okay. So first of all, I want you to understand something. So let's suppose you have a function. Okay. We have a function g of x. Okay. So we have this function g of x and it's equal to axn plus b, like that. Now, let's suppose they ask us to integrate this function with respect to x. So what you'll see is a symbol that looks like this. So you read this as the integral of axn plus b with respect to x dx, like that. Now, how do you integrate this function? So we're going to use something called the power rule, okay? So we shall use something called the what? The power rule. Now, according to this rule, if we want to integrate a function which has this form, okay? Yeah, this is what I want you to always do. So you shall say, so what you're going to do to this power of n, so ax, what you do to the power, you increase the power by 1, then you divide by the new power, okay? So this one becomes axn, then plus 1. So you increase the power by 1. Then you divide by the new power, this is plus 1. You divide by this same new power now, meaning you divide by n plus 1, okay? Then if you have a constant that has no x, what you just do to it is just you give it an x, okay? So this one becomes plus bx, then plus c, okay? So you should always add a constant. So when we integrate this one and we add the value of c, we say plus c there, we are not getting the exact value, okay? Because we're not getting the exact value, we call this the indefinite integral, okay? So when you're finding the indefinite integral, you're just finding another function, okay? You're finding another function, we're adding the value of what there? C, okay? So we call this the indefinite integral. But if I have something like this, let's suppose we have the same one. So we have the integral axn plus b dx. But this time around, we now have what we call the limits. I'm integrating this, let's say, from A to B, okay? Yeah, I'm integrating this from A to B. So I'll apply the same rule, the power rule. So this will still be axn plus 1. Then I divide by n plus 1. Then plus bx, like that. But this time around, I'll not say plus c. I'll now find the exact value. So I'll integrate this now from between the limits a and b. So I'm integrating this now between a and b, okay? So what you do with these limits now is that they will allow you now to find an exact value. This time around, you are now finding an exact what? Exact value. And this exact value represents the area of that function between the limits a and b. Okay, I'll explain more about what I mean by we are finding the area. Now, how do you handle these limits? So what you do now is, once you find this function, okay, you now substitute. These will be values. Let's suppose maybe this is 1, this is 2, okay? Yeah, so this is the lower limit, that is the upper limit, okay? So you're going to substitute now. You shall say f of b minus f of a. What I mean here is that you're going to get the value of b. Let's suppose it's 2. You substitute it in for the value of x here. When you find the value, you shall say minus f of a. Okay, so you understand more when we start solving that problem. Yeah, now I'm saying this gives you now the exact value, which is the area. Because you are getting an exact value, we are going to call this the definite. This is now a definite what? Integral. Now, this definite integral actually gives you the area of the function between these two limits a and b. Let me explain more. So let's say our function g of x has this particular graph. It looks like this. This is our function, okay? Once I integrate this function from a, this is a value of x, to b, okay, I'm finding the area of this function below the graph, okay? Below the what? The graph. So I'm finding this area, like that. So if they ask me, find the area of this function g of x, what do? I just need to integrate g of x from this limit a to b, okay? So I integrate g of x like that. Then I'm finding this area, okay? Now, sometimes you could have two functions. So let's say I have something like that. Let's suppose you have this function that goes like that. Let's call it f of x. And another function that goes like that. Let's call it g of x. Then they ask you to find this area. Okay. So if I want to find that area, what do? So you can see that first of all, so this one, let's say this is 0, and it goes maybe this value here is a. So I need to integrate. Once I integrate this function, the upper function, from 0 to a. So if I integrate this upper function, let me call it area 1, from 0 to a, I'm finding the area that is below the graph, okay? So in other words, I'm finding this area. I'm finding everything there, everything, like that. You see that, right? Yeah. So once I integrate this upper function, I'm finding everything. Now what I want to find is this shaded area, the one shaded in black. What do? I need to integrate now this other function. So if I integrate this other function from 0 to a, then I'm also finding the area. You always find the area that is beneath the graph. So I'll find the area that is beneath this one. And you can see, if I have this area and the total area, to find the area of the shaded region now there, I'll just say this area minus that area, okay? So you can actually also just find this and say the area here is, because they are all going from the same limits, okay? They have the same limits from 0 to a. So I can just integrate from 0 to a. I say I'm integrating f of x. This will give me the total area minus, I also integrate from 0 to a, okay? I'm integrating from 0 to a now what? G of x. Of course, it's dx. So that gives you the area of the what? The shaded region. Of course, you can also just write this because they are all moving from 0 to a. I can just have one thing here and say 0 to a, then f of x like that, minus g of x dx. Okay. Okay, let me just start solving the problem so that you can understand more. Okay. Okay, so the first question here says find the coordinates of a and b. Okay, find the coordinates of a and b. So if I want to find the coordinates of a and b, because the two functions are intersecting, once they intersect, to find the points where they are intersecting, you need to solve the equations simultaneously. Okay, so I have y equals negative x. I also have y equals 2 minus x squared. So we're going to solve these two equations simultaneously. Yeah. So you can see I can just make y is already the subject here. So it means where there's y here, I can substitute with negative x. So where there's y here, I can have negative x equals 2 minus x squared. Okay. Okay. Let me just bring these to the other side. So when this one comes to the other side, it will be positive x squared. Then here we have minus x. Then this will be minus 2. Then what we have now there is a 0. So we can now solve this quadratic equation. Okay, so let's find the product, the sum, and the factors. Okay, so the product 1 times that is negative 2. The sum is always b, which is negative 1. Factors, what two numbers can I multiply? Give me negative 2, but when I add them, I should get negative 1. So it's negative 2 and 1. Then I'm going to have x squared. So I write this in terms of x, so minus 2x. Then this one is plus 1x, so plus x minus 2 equals 0, excuse me. Okay. Yeah, so I factorize here. I also factorize by grouping. So here I shall have x minus 2. Here positive 1 is common. Then x minus 2 equals 0. You can see x minus 2 is common. Then here I'll be left with x plus 1 equal to 0. So when we solve for x here, you can see that x is equal to 2 or x is equal to negative 1. Okay, you set each piece equal to 0, then you find for x. Now that we have x equal to 2 and x equal to negative 1, we need to find the corresponding value of y, because the question says find the coordinates. For a coordinate, you should have x, comma, y. So for each value of x, we need to find the corresponding value of y. So when x is 2, we know that y is negative x. Okay, so y is negative x. So if x is 2, it means y is negative 2 here. And if x is negative 1 there, it means y is positive 1, because y is negative x. They are opposite to each other. Yeah. So it means we now have 2 comma negative 2. We also have negative 1 comma negative 1. Okay. So we now need to figure out which ones will be the coordinates for A and which ones will be the coordinates for B, depending on the position of the 2 points. Okay. Yeah. So you can see that A is on the left side, okay? It's on the negative side. So you can see that the value of x here is negative and the value of y is what there? Positive. So, oh, here I made a mistake, sorry. This part, we found y to be positive 1. So this should be positive 1 there. Yeah. So we can now conclude here and say, therefore, so what are the coordinates for A? So A has the x value there is negative, the y value is positive. So it means that this is the one, these are the coordinates for what? For A. So negative 1, comma 1. Then B will be 2, comma negative 2. And it makes sense because the value of x there is positive, the value of y is negative. So this gives you the answer and your 3 marks. Then let's now go to the next question. It says determine the area of the shaded region. So to find the area of the shaded region, we shall use calculus, we shall use integration here. So what we need to understand first of all is that we have this function. Once I integrate this function from this value of x here to this value of x, so from there to there, I'll find the area that is below the graph, okay? You can see it looks like this. So if I integrate, I have a value of x there and another value of x there. So if I integrate between these two values of x, between these two limits, here we have x equal to, we just found x as what there? As negative 1. So here we know that x is negative 1 there and x is 2 there. So if I integrate this function from negative 1 to 2, I'm finding everything that is what? Below there. I'm finding the area that is below the graph. Okay, that is what I'm going to have. I'm going to have this area here. But if I find now, if I also integrate this other function, okay, this other function, from the same limits, negative 1 to 2, I also find the area that is below this graph. Then once I subtract everything, so I said everything minus this, I'll remain with what? The shaded region. That is what you want to do there, okay? So we can also just say the area of the shaded region will be the integral. It will be the integral from negative 1 to 2 of the upper function, okay? The upper function, which is y, which is a curve y is 2 minus x squared, I can call it f of x if I want, then minus the lower function, this one, which is g of x, okay? Like that. So I'm going to integrate these ones with respect to x, dx there. So once I integrate these and from -1 to 2, then I'm finding the area of the shaded region. So let's just do that together. Okay. So our next step is to write down the integral. Yeah. So our area. So our area will be equal to the integral, okay, from -1 to 2, okay, yeah, of the upper function minus the lower function. So the upper function was this one, the curve, 2 minus x squared. So 2 minus x squared, right? Then minus the lower function. The lower function was -x. So minus -x, like that, okay? Then I'm integrating this with respect to what? To x. So once you write down your integral like that, then you just need to start computing it. So let's find the area of the shaded will be from -1 to 2. So let's simplify what's inside there. So 2 minus x squared. So negative times negative there, positive. So plus x, then dx like that, okay? Yeah. Then let's now use the power rule and integrate what we have there, okay? So remember, if I just have x there, the power here is 1. You need to take note of that. So let's integrate that. So our area will be equal to, so if I integrate 2, it's a constant. I said you just give it x there. So this will be 2x, then minus x